Okay, now I'm still in the future here, but I have one more thing to mention before I go back there to the past. That the last video, I had gone back and replaced the ending part, and the video to follow this introduction here is the original concluding section of the one that I changed. So I just wanted to let you know that there has been an extra video added, just because the other one's getting a bit long. So I'm going to keep the remainder of the previous video that would have come in the previous slot, and now it's just following this introduction. Okay, and in this next video, I will begin to discuss the concept of virtual functions, but I won't be answering those questions. The answers, though, will be you should be able to figure out what the answers are if you understand what follows now. Here will be public, maybe not defined here, at least declared here. And what I want to do is I'd like to, well, okay. So I type def of a function whose return value is void, and it's a pointer to something like that. And now I'm going to call this a return value void pf pointer to function taking a void, and I want it to be a const. I want it to be something that doesn't modify the object, and I guess I could put the const here. Void pointer to, and how about constant function taking void. I'm inventing my own wrangling. So here's the actual definition. A void function, pointer to base, taking a void parameter, does not modify the base object, so it's const, and that's a type def. Okay, now what I would like to do is declare well, I'm going to introduce a new keyword called protected, and I'll tell you what that means as I go along. And in here is where I want to define I want to declare one of these pointers. Okay, that's a member pf virtual func. So I have a pf virtual func. All right. Now this would not be available to somebody who creates a base object. First, let's define the constructor. Now I'd like to set this equal to something. So if I make a function here, well, what I'd like to do is make a function that calls this function first. So how would I do that? I would like to make a function, a void, that's actually of the same type, void, call it call vfunc const, and that should return. Now we need to use the special arrow star operator, and the name of the data. I'm going to do brackets around because of the glue, the star glue. Okay. Now that so far, if I called this function, that's going to call whatever this points to. Now I'd like to actually create a function, and I'm going to make that function private. And I'm going to call it void func vert func vfunc constant. And what do I want that to do? I want to finally note this. Print out its name. Now this call vfunc is public. Right? And if I just simply set this pointer to point to this, we'll be able to call that private function through the public interface. Address or base vfunc. Okay. All right. Now, first, let's see if that works. Call the vfunc. Oh dear, I missed now. Oh, I typed that. I need this to be public, but I want that to be protected. I have to use my trick. To do this on one line. Alright, so I'm going temporarily to public and then back to protected. This should be on this line. So, I usually do it if I want to make something temporarily public, I'll go public thing and private, and then eventually this becomes a macro, and it won't look so ugly the next time. Alright, so now first let's just make sure that I have no access to this. This should not compile. Okay, cannot access protected member, nor am I able to access vfunc. Not allowed. Okay. The only way I'm going to be able to call vfunc is through this magic interface. Call the vfunc. That's allowed. That's public. Now let's see it work. So that puts me in here. That calls something, which calls this, prints out its name. Okay, private base vfunc void const. So it worked. Oops. Now okay, so now this here, I'm telling you right now, is exactly the most simple definition of a virtual function. Why virtual? Suppose we have another class called Derived, and exposes and derives from base. Okay, so now this has inherited all of the interface from base. Now what I would like to do with this derived thing is override this property function by replacing this variable, which I'm allowed access to through this protected keyword. That's what protected means. It means not accessible to the outside world, but accessible to derived classes. So this guy can modify this value. And what I'd like to do is in the constructor of my derived class, I want to set that value to my own function. I don't have to give it the same name, and I don't have to make it public. Doing the virtual dance, and that will print its name out. Okay, and that's what I want. That's what I want to set this equal to. I would like to set this value equal to that. Now first it's going to complain because it's not the same type, but if I simply cast this as one of these things, all my troubles should go away. Missing semicolon, true enough. Alright, now to further complicate matters, I'm going to create a function called foo, which returns to me, well, let's see that this works first off. I'm going to create a derived and call vfunc. Now remember, vfunc is not a member of derived itself, it's an inherited member. So now I can just F5 or just step through it. Let's step through it at least once. That takes me here, and now that's going to take me here. Prints out derived, okay? Different name, everything. So that's fine. Now the first question that should come to mind as I'm writing this down I'm going to start here. Is what about the data? When this do the virtual dance gets called, will it get the data that I might define in the derived class or not? Now, how do I want to do this? There are two kinds of experiments I want to demonstrate. Well, let me do the easy kind first. One where I'm passing this to a function, taking either a base or a derived or a pointer to or a reference to and so on and so forth. Let's suppose that foo takes a base type object, and I want to call foo with my d, and that. So now that's a valid call because the base contains this function. Here I'm calling this with a copy of a D object. Now again, because of this business with copying, this base here that gets put on the stack is going to be created via the default copy constructor for my derived class, which, as you can probably guess, is not going to copy this particular value. Let's see if that's true. I can just F5, but you'll notice that it did work. You see? Here I've passed an object which is not a pointer or reference to a function which takes an object of the base class type, and the function that got called wasn't the one from the base class. Now the reason for that, and this doesn't happen with actual virtual functions, thankfully, the reason for that is because this data member is actually a member of the base. Okay, now all I've done here is modify that member. So the default copy constructor copied dutifully the members of the base class, and that included my D. Unfortunately, since it didn't copy all of my D, and it's using one of my D derived functions, then any data that I declared in here would not have been copied, and I certainly wouldn't want the virtual dance function to get called in that scenario. So in fact, this here would essentially be an error. This is in fact an error. Okay, so that's one thing. Okay, actually let me just stop here. Okay, well, one more experiment. If this was a pointer instead, okay. Now I'm gonna tell you that this is okay. I'm gonna prove it. First, I'm gonna add some data to my derived. Which I'm going to initialize to 0, and here in this thing I'm going to print out in hex, because you'll see why in a minute. Go back to the original. I want to show you why this is a mistake. Whoops. Percent. Okay, now. I equals some weirdo value, not the one that it's supposed to be. Right. But it should actually not, it should be C C C C C. When it's copied, when this is copied, it's certainly not not 0. But I expected something else. Hang on a sec. Oh, okay, I see what it's printing out. That number was 401041, I think. To run through it. To run that. Oh, I haven't done it yet. Okay. Foo of D. Call the V. The number that gets printed out here. 401041, right? Is the reason it's that particular number is because that there is the address of the first member, right, of the class, of whatever is the class is that I copied on the stack. And all that's happening is when I get into here, okay, everything's been copied from the base class, right? So that includes this only, this and only this. Now this do the virtual dance function is going wants to print out the first element in this struct called derived. So it's interpreting when we get to here and the breakpoint, it's going to interpret I as though it were the integer that it had declared, which is incorrect. In fact, this object, the object that's being passed into here, is just an object of type base, which has a member, and that member happens to be the pointer to this particular function that we're actually in. If you wanted a way to get the address of the current function, that's one not roundabout way to do it. Step long enough for this pointer will show up. So here we are, okay. I here is not what we initialized it to. In fact, if we reinterpreted this as a base star, then that is the correct interpretation. It's member function 40101 is the thing that we set it to. So that's why this is incorrect. What's happened here is we have not found a way to make a copy of D and pass it to a function that doesn't take a pointer or a reference. And in the next video, I'm going to show you how we can pass the entire object by simply passing it as a pointer or reference, and then this will get called and we will have access to I. Okay? Alright. See you next time.